Hi there, I'm Professor Rafael Bonato, and I welcome you to the second module of a food chase training. I hope you enjoy this training, you take the best of it, and you dive deep into the material that I have written, I have put together for you. And let's start our class today. We'll be talking about specifically regarding the smart and sustainable food production systems. And the module itself is directly connected to the food loss prevention and quality control, such as processing, storage, and handling. Let's start our class. First part of our class will be just introducing you to the learning outcomes of such a module. And we have divided into 5 different outcomes as follows: execute, raw material preparation techniques that optimize yield and preserve functional quality. This training will be focusing on how to understand and how to put it together, as well as apply correct processing operations to minimize food loss and waste. You will see again that food loss and waste will be something that we'll be touching always, talking about and finding the best way to avoid or decrease it, better saying. The third outcome is implement storage and handling practices aligned with the European Union food safety and traceability rules. So understanding how to implement such storage techniques and processing to better have a better product at the end of the cycle. Okay. Yet reduce contamination risks, mechanical damage, and quality decay, as well as identify food loss drivers within food production lines and propose corrective actions. This last learning outcome is very important for you who is acting directly into the food industry. And the idea is bringing some ideas by showcasing some interesting exercise for you. Okay, let's start our class. Just an introduction to the module. The theme, remembering food loss prevention and quality control, processing, storage, and handling. Food loss and quality deterioration frequently originated during raw material preparation, so at the beginning of our cycle, processing, storage, and handling, long before products reach consumers. Many people think that the majority of the wastes are generated by the last consumer, but not. Actually not. It starts on the farm and goes all the way to the last consumer. But in between those two actors, those two processes, or maybe pillars, we have the industry where we as professionals can act accordingly to decrease such wastes, okay? Within the European Union, regulatory frameworks such as the hygiene package and the farm-to-fork strategy demand high levels of technical precision, traceability, and sustainability. You will see on the written material that farm-to-fork strategy is always present, and we mention a lot, mentioning some of the rules, some of the advice based on such a strategy, okay? And just to wrap up this slide, these sub-modules adopt a system-based approach, emphasizing how early operations decision influence efficiency, safety, sensory quality, and waste generation across the value chain, okay? Regarding this part of the presentation where we talk about this theme, which is the second theme, preparation techniques that optimize yield and preserve functional quality, we must, you are advised to read about EU policy context. Regarding these specifically, you will be able to see on the footnote of the written material that you can click on the link or maybe just copy and paste the link, and it will take you directly to the link where you'll be able to see the document as a whole itself to understand the policy context, okay? But just to introduce you to the farm and folk strategy, which is central to European Green Deal, which establishes the following targets: reduce pesticides and fertilizer use, understanding this is a main barrier for sustainability; lower antimicrobial dependency, understanding that for having a food that's better, is more sustainable, more regenerative system, we must understand how to produce depending less on antimicrobial substances, okay? As well as expansion on organic farming, okay? And improve sustainability and traceability. Sustainability is a very broad concept, but we try to put it together regarding the food industry, such as the way we produce, the way we process, with the way we deal, okay? And traceability reveals how the product has been produced and how to trace it back to the origin, all the way from the origin to the supermarkets, understanding if this or that product is connected to sustainability or they are complying with the European Union policy, and etc. Okay? These policies reinforce the need for preventive quality management. Remember, preventive, from the first class, we have defined the difference between preventive and other types of, other typologies of quality management, where food loss reduction is embedded in daily processing decisions, okay? The third subject, preparation techniques that optimize yield and preserve functional quality. We have a food, it must be quality functional, meaning that if I buy something that's rich in vitamin C, it must be rich in vitamin C. What should I do as a technician? What should I do as a food processor to keep such vitamins and such nutritional properties, okay? The objective of it, maximize edible yield while preserving functional, which is the vitamins, an example, sensory, which is taste, flavor, and smell, and safety attributes of raw material. Safety attributes is that, is it safe, is it sane? It must be. Core preparation operations, normally washing, selection, trimming, sorting, and pre-processing, okay? You can see the figure on the right-hand side of our presentation, which the link is right on the footnote, on the foot of the page. You can just click in and it leads you directly to the page where you can actually explore such a figure, which is connected to the applications of multi-objective optimization on food engineering, which has a different spheres of goals and examples, okay? This is a very interesting article. I advise you to read and it will help you understanding more about such a preparation techniques, okay? The next slide, still on the same subject. Now we're gonna be exploring what each of those different core operations, washing, selection, trimming, sorting, pre-processing, okay? Washing, the main objective of washing, remove soil, organic matter, pesticide residues, and surface microorganisms. It does combine mechanical turbulence with approved sanitizers. The mechanical turbulence is a water, normally a water jet, that just pushes the substance that are on the skin out of it, okay? It's more a mechanical removal. That's why we call it mechanical turbulence. With approved sanitizers. Sanitizer would be substance that are approved by European Union, specifically farm fork strategy, that you can be used for such. Can reduce microbial load by 1 to 3 log CFU, which is a measure. You will see that on the material. Requires potable water and validated sanitation protocols under European Union regulations. The European regulation number is 852/2004. You can click on that and understanding more if you decide to go deeper on that, and or if your role requires you to do. And the last, one of the last points that we have mentioned here is advanced systems such as ozonate, ultrasonic pressure assisted, which improve safety while reducing water use. These are techniques, innovative technologies that try to decrease the water usage while actually eliminating such organic matter, pesticide residues, and surface microorganisms, okay? Second, selection acts as an early quality filter, okay? If you do the selection, you will be able to choose which fits and which does not fit. That's why we say early quality filter. Preventing downstream losses, okay? If you do it at the beginning of a process, it saves you and prevents you on the downstream losses, okay? Avoid you applying energy into something that at the end of the process will not result in a good product, okay? Evaluates maturity, structural integrity, chemical compositions and defects. Uses optical, spectral, and AI-based technologies. Nowadays, we're using a lot of those technologies to actually select it by ultra-red, infrared, many different types of technology to pre-select, you know, before it gets into operational handling, okay? Reduces batch heterogeneity, meaning that on the batch, on the shelf, you have a more homogeneous product. Improves yield and supports PDO, PGI compliance. PDO is a protected denomination origin and geographic origin. Okay, is what we call the quality brands. Okay, and strongly linked to waste prevention and process efficiency. Trimming, you see one example here, removes damaged, contaminated or non-edible portions. Remembering, it's very key. Requires precision to avoid excessive edible yield loss. When you trim, you gotta trim right on the part you don't want, instead of just chopping half of it. Sometimes you don't even need to chop no more than 5%. Sharp blades and standardized cuts reduce oxidation and microbial risks. Excellent. Poor trimming can reduce yield by 5 to 12%. Imagine only on the trimming phase, if you lose 5 to 12, you are losing a lot, because each of the phases of the production line, you lose a bit. That's why we are trying to avoid losing on this phase of trimming. Essential for hygiene, compliance, sustainability, performance. Very key. Sorting. The right-hand figure, here you can see on the right-hand side of the figure, it's a technology that actually, it's a camera that we call a hyperspectral camera. We normally use this for soil analysis as well. It helps identify the standard, the patterns of what you are selling. In this case, is a meat, is a beef. Helps keep the quality, example, identify the amount of fat on each of the steaks. Helps you classify and have a more homogeneous batch, quality. Okay, this is one example of a very, very high level technology used in the food industry, and we call it sorting. It ensures uniformity in size, shape, maturity, and density. Those cameras just help us finding that. This is just one example. Improves heat transfer predictability and equipment performance. Uses machine vision, hyperspectral imaging, and X-ray systems. Reduce overprocessing, microbial risks, and product rejection. And it's critical for EU marketing standards and quality schemes. So it does converges and attends the European Union Farm to Fork strategy and other legislations. Okay, by keeping quality, keeping maturity, keeping nutritional density, and etc. So those mechanisms such as SWIR camera, which works on the hyperspectral camera, they help us a lot. Instead of using our eyes, we can use something standardized that avoid problems or decrease problems. Okay, and pre-processing, still on the preparation techniques, includes peeling, slicing, blanching, conditioning, milling, and hydration. And the key functions is enzyme inactivation like PPO, POD, and PME, structural stabilization, moisture and particle size optimization, and improved thermal and mechanical efficiency. Okay, the figure on the right-hand side of your screen just shows how we follow those pre-processing techniques from the tree itself, from the farm, all the way to the finished product. Okay. There is a link for this figure on the document shared with you. You can click and go direct to the page and understanding more this figure. And the main idea of such pre-processing is to optimize pre-processing significantly that will reduce losses and protect nutritional quality. Not just protect, but reduce losses. Okay, very key to this. Regarding the applying correct processing operations to minimize losses, just missing here, the objective is ensure microbial safety and product stability without overprocessing while minimizing waste generation. And some of those techniques would be the cutting, which determines surface area, tissue damage, and oxidation rates. It does a bit of different bullet points. We have put it here. There are 5 of them. It helps dull blades increase drip loss, browning, and microbial susceptibility. Precision cutting improves yield and shelf life. Advanced systems such as ultrasonic water jet minimize mechanical stress, and high-risk hygiene control point under EU legislation. These are the main objectives, the main results of cutting properly, okay? Heating, which is one of the right process, ensures microbial lethality and enzyme inactivation, okay? Overprocessing causes nutrient loss, texture damage, and yield reduction if we actually heat over the accorded or the accepted standard. And optimize the heat transfer models, reduce waste and energy use. This figure on the center of our screen just defines under the food farm to fork strategy what is classified as freezer, fridge, hot, holding, reheating, and cooking. These are the temperatures, all in centigrades, that actually defines the process. It's not just a number. This number is under registration, and we must follow this, okay? Cooling. How do we understand this cooling? Rapid cooling and how it benefits the food processing operations to minimize food loss. Rapid cooling prevents microbial growth and enzymatic reactivation. Okay, critical for maintaining shelf life and safety. So you have more days of a product into the supermarket, saving you from losing or spoiling it on the supermarket. System included forced air, vacuum, hydro, and cryogenic cooling. We call it cryogenic cooling, is a type of cooling that's very low temperature that helps preserve the food, okay? Always to decrease and to minimize wastes and losses, okay? Mixing and homogenization. Ensure uniform composition and stability. Poor mixing leads to rework, rejects, and waste. This is very important. You will see that the details are always present on the food industry. That's why we must mix properly. We must ensure uniform composition and stability, okay? To avoid losses, like I say. You see on the right-hand figure, the food industry and foodonomics. It's like the economics for the food system. This is a very interesting graphic. It has been depicted from a paper that you can access. I think it's a paper from 2022. It's pretty new paper, but just show how the process, you know, they help decrease such and minimize such a losses by using high-level technology on the process, okay? Just turning to the left-hand side of our presentation, the fermentation, which requires strict control of pH, temperature, culture, and oxygen. Deviations can cause total batch failure. Fermentation is something very, very susceptible of a miss. If you don't do it properly, you can actually, such as deviation of process, you can lose the entire batch. And this is very serious, specifically when you're working with a high input and high cost input, such as milk and dairy products, okay? And the packaging, just walking to the end of our process, the packaging, final protective barrier against contamination and oxidation, helps saves everything that you have done from selection process all the way here. MAP and vacuum packaging extend shelf life, okay? And packaging failures are major waste drivers. And this is very sad because if you have done all the previous steps accordingly and at the end of the very last phase, the packaging failures, you will have the major waste of drivers. So that's why it's so important, okay? This was our module number 2 presentation. I hope you enjoyed this module. It's been very quick, and the main idea here is to pre-introduce you to the concepts that will be reinforced by your reading of the written material, plus all the references that we have shared with you, where you can click and go directly to the page, directly to the scientific article to dive deeper into that. I hope you have enjoyed the class, and I see you on our module 3. Thank you.